NASA's Mars rovers have been one of the great scientific and space successes of the past 2 decades. Four generations of rovers have traversed the red planet gathering scientific data, sending back evocative photographs, and surviving incredibly harsh conditions, all using on-board computers less powerful than an iPhone 1. The latest rover, Perseverance, was launched on July 30, 2020, and engineers are already dreaming of a future generation of rovers. While a major achievement, these missions have only scratched the surface, literally and figuratively, of the planet and its geology, geography, and atmosphere. The surface area of Mars is approximately the same as the total area of the land on Earth, said Masahiro Hiro Ono, group lead of the Robotic Surface Mobility Group at the NASA Jet Propulsion Laboratory (JPL), which has led all the Mars rover missions, and one of the researchers who develop. Imagine, you're an alien and you know almost nothing about Earth, and you land on 7 or 8 points on Earth and drive a few hundred kilometers. Does that alien species know enough about Earth? Ono asked. No. If we want to represent the huge diversity of Mars, we'll need more measurements on the ground, and the key is substantially extended distance, hopefully covering thousands of miles. Traveling across Mars' diverse, treacherous terrain with limited computing power and a restricted energy diet, on. The first rover, Sojourner, covered 330 feet over 91 sols. The second, Spirit, traveled 4.8 miles in about 5 years, Opportunity, traveled 28 miles over 15 years, and Curiosity has traveled more than 12 miles since it landed in 2012. Our team is working on Mars robot autonomy to make future rovers more intelligent, to enhance safety, to improve productivity, and in particular to drive faster and farther, Ono said. New hardware, new possibilities. The Perseverance rover, which launched this summer, computes using RAD 750s, radiation-hardened single-board computers manufactured by Bay Systems Electronics. Future missions, however, would potentially use new high-performance, multi-core radiation-hardened processors designed through the High Performance Spaceflight Computing (HPSC) project. Qualcomm's Snapdragon processor is also being tested for missions. These chips will provide about 100 times the computational capacity of current flight processors using the same amount of power. All of the autonomy that you see on our latest Mars rover is largely human in the loop, meaning it requires human interaction to operate, according to Chris Mattman, the Deputy Chief Technology and Innovation Officer at JPL. Part of the reason for that is the limits of the processors that are running on them. One of the core missions for these new chips is to do deep learning and machine learning, like we do terrestrially, on board. What are the killer apps given that new computing environment? The Machine Learning-Based Analytics for Autonomous Rover Systems (MAARS) program, which started 3 years ago and will conclude this year, encompasses a range of areas where artificial intelligence could be useful. The team presented results of the MAARS project at HIEEE Aerospace Conference in March 2020. The project was a finalist for the NASA Software Award. Terrestrial high-performance computing has enabled incredible breakthroughs in autonomous vehicle navigation, machine learning, and data analysis for Earth-based applications, the team wrote in their IEEE paper. The main roadblock to a Mars exploration rollout of such advances is that the best computers are on Earth, while the most valuable data is located on Mars. Training machine learning models on the Maverick 2 supercomputer at the Texas Advanced Computing Center (TACC), as well as on Amazon Web Server. Energy-optimal autonomous navigation. Ono was part of the team that wrote the onboard pathfinding software for Perseverance. Perseverance's software includes some machine learning abilities, but the way it does pathfinding is still fairly naive. We'd like future rovers to have a human-like ability to see and understand terrain, Ono said. For rovers, energy is very important. There's no paved highway on Mars. The drivability varies substantially based on the terrain, for instance beach versus bedrock. That is not currently considered. Coming up with a path with all of these constraints is complicated, but that's the level of computation that we can handle with the HPSC or Snapdragon chips. But to do so we're going to need to change the paradigm a little bit. Ono explains that new paradigm as commanding by policy, a middle ground between the human-dictated, go from A to B and do C, and the purely autonomous, go do science. Commanding by policy involves pre-planning for a range. We use a supercomputer on the ground, where we have infinite computational resources like those at TACC, to develop a plan where a policy is, if X, then do this, if Y, then do that, Ono explained. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.